Now let us try to understand the next problem in the NP sequence, which is termed as GPT. So what is GPT? GPT stands for graph partitioned into triangles. So basic idea is given a graph of vertices and edges, it is required to find out whether there exists a complete graph of size 3. When I'm saying size 3, I mean to say 3 vertices. So given a graph, find out whether there exists a complete graph of size 3 is denoted as GPT. For example, in this graph, there are many such subgraphs which are of size 3 and which are complete in nature. For example, ABC. Why this particular problem falls in the category of NP is for a very large graph, finding such solution will take very large time, but once the solution is generated, its verification can be done in fixed time. So why GPT is NP basically is clear from the fact that if you try to implement this problem on a large graph, finding a triangle in that large graph may require some time. But once the triangle is generated, then verifying that particular point or particular set as triangle set is done in polynomial time. For example, if I generate here CEF as one set, S1, and one set as A and C and E, then probably verifying this as a this particular set as not GPT and verifying this particular set as GPT will be done in polynomial time. So that's why this particular problem is categorized as NP. Now let us try to further understand, can we take or can we classify GPT as NP complete? So in the previous discussion, I have given you the idea about what is NP complete. To prove any given problem as NP complete, first prove it as NP, then find the set of problems which can be finally mapped to or reduced to the given problem which we want to basically prove it as what? NP complete. So this set may have single problem also. So according to our knowledge till now, we know the problem click, and if we can reduce this click to GPT in polynomial time, then GPT will be classified as NP complete. For example, if you recall, we have written a for loop in the form of for I equal to 1 to t while we have generated the click in the algorithm. This t stands for size of click. Okay. Now, if I replace this t by size 3, then I'm only selecting the vertices from the given graph, and number of vertices selected in this set will be restricted to 3. And then I can check whether these 3 vertices are interlinked in a complete form in the graph. So this verification can be done in polynomial time, but this selection is random, and this selection may or may not work, and it may not work anytime, and it may work in the first go itself. Hence, there is a non-determinism here, and the verification is done in polynomial time. So we call this GPT as NP complete. Hope you understood the idea of NP complete in this video.